take the slap shot, I took one step towards the ball, swung my stick, and shot the ball. The ball covered 6 meters in 0.16 seconds. Initial vertical velocity. For the givens list, the displacement is 1.22 meters. The acceleration due to gravity is 9.8 meters per second down. The time is 0.16 seconds. Now we have to find the initial vertical velocity. I plugged my numbers into the equation and figured out that my initial vertical velocity was 7.784 meters per second. Therefore, the initial vertical velocity is 7.9 meters per second. Final vertical and horizontal velocity. By looking at this picture, you can see the horizontal and vertical displacement. For the givens list, the vertical displacement is 1.22 meters, the acceleration due to gravity is 9.8 meters down, the time is 0.16 seconds, and for horizontal, the displacement is 6 meters and the time is 0.16 seconds. Now we have to find the final vertical velocity. As we have already figured out, the initial vertical velocity is 7.784 meters per second. I used the equation final velocity squared equals initial velocity squared plus 2 acceleration times displacement. I plugged in all my numbers and eventually got vertical velocity squared equals 82.5426. I had to square root that so I could get VF by itself. After I did this, I figured out the final vertical velocity is 9.0853 meters per second. To figure out horizontal velocity, I used the equation velocity equals displacement over time. As you can see, horizontal velocity equals 6 meters over 0.16 seconds. After doing the calculations, I figured out the horizontal velocity is 37.5 meters per second. This picture shows the final vertical velocity and the horizontal velocity. Now I'm going to use Pythagorean theorem to figure out the velocity of my shot. For my givens list, A equals 9.08 meters per second, B equals 37.5 meters per second, and now we have to figure out C. I used the equation A squared plus B squared equals C squared. I plugged in all my numbers and figured out that 1488.6964 equals C squared. I then had to square root that number to get C by itself. I ended up figuring out that C equals 38.5487 meters per second. Therefore, the final velocity of my shot is 38.5 meters per second, which means the maximum speed of my shot is 38.5 meters per second. Acceleration. For my givens list, my final velocity was 38.5487 meters per second. My initial velocity was 0 meters per second because the ball was at rest. My time was 0.16 seconds. Now we have to find acceleration. I use the equation acceleration equals final velocity minus initial velocity over time. I plugged in all my numbers, so its acceleration equals 38.5487 meters per second plus 0 meters per second over 0.16 seconds. After doing the calculations, I figured out the acceleration is 240.9294 meters per second squared. Therefore, the acceleration of my shot is 240.93 meters per second squared. Average vertical velocity. For my givens list, the final vertical velocity is 9.0853 meters per second, and the initial vertical velocity is 7.784 meters per second. Now we have to find the average vertical velocity. The way I figured this out is by using the equation average velocity equals initial velocity plus final velocity divided by 2. When I plugged in the numbers, I got average velocity equals 7.784 meters per second plus 9.0853 meters per second divided by 2. This showed that my average vertical velocity equaled 8.43465 meters per second. Therefore, the average vertical velocity is 8.43 meters per second. Net force. For the givens list, acceleration is 240.9294 meters per second squared. The mass is 23 grams, which got converted to 0.023 kilograms. Now we have to find F net. The way I got this is by using the formula net force equals mass times acceleration. After plugging in all my numbers, I found out that my net force is 5.5414 joules. Therefore, my net force is 5.54 joules. Free body diagram for a stationary ball. This has the force of gravity and normal force. These forces make the ball stationary. Free body diagram on ball getting hit by a stick. This also has a force of gravity and normal force on it, but also has applied force. It's because the ball is applying a force back to the stick that's hitting it. Free body diagram for floorball stick hitting a ball. Just like the other two, this one also has a force of gravity and normal force on it. It also has applied force. It's because the stick is applying a force to the ball to make it go forward. Also, by the stick hitting the ground, there is kinetic friction. Energy transfer of a slap shot. It goes from potential energy to kinetic energy. Then it goes to thermal energy that loses some energy from elastic energy and sound energy. Then it goes back to kinetic energy. To go more into depth, the player raises his stick, creating gravitational potential energy. By the player swinging his stick to hit the ball, he creates kinetic energy. A little bit of thermal energy is lost because of air friction, but a lot of thermal energy is lost through the friction of the blade and the floor. The player flexes the stick as it impacts the floor, creating elastic potential energy. A little bit of energy is lost through the sound of the impact with the floor and the blade. The stick releases the ball with a spring-like action, shooting it off at a high velocity, thus creating kinetic energy. Potential energy. By looking at this video, you can see the height is 0.9 meters. For the givens list, the mass is 0.023 kilograms, the acceleration due to gravity is 9.8 meters per second squared down, the height is 0.9 meters. Now we have to find the potential energy. To figure this out, I use the equation potential energy equals mass times acceleration due to gravity times height. This gave me potential energy equals 0.023 kilograms times 9.8 meters per second squared times 0.9 meters. By doing the calculations, I figured out that potential energy is 0.2029 joules. Kinetic energy. For my givens list, the velocity is 38.5487 meters per second, the mass is 0.023 kilograms. Now we have to find the kinetic energy. To figure this out, I use the equation kinetic energy equals 1 over 2 mass times velocity squared. After doing all my calculations, I figured out the kinetic energy is 0.443 joules. Newton's first law, the law of inertia. Newton's first law states that an object at rest will stay at rest unless an unbalanced force is acted upon it. As you can see, the ball is staying at rest until the stick hits it, creating an unbalanced force making it go forward. Newton's second law. Newton's second law usually talks about the net force of an object going in a straight line, but it also can talk about a net force of something going in a circular path. When an object moves in a circle, its velocity changes direction. Since the velocity is changing, that means there is acceleration, and knowing about Newton's second law, you know if there's acceleration, there is a net force. Newton's third law. Newton's third law states, for every force, there is an opposite and equal reaction force. As you can see, the stick is applying a force to the ball, so the ball is applying an opposite and equal reaction force to it to make the ball go forward. Work of stick hitting the ball. This picture shows vertical and horizontal displacement. Now I'm going to use Pythagorean theorem to find the displacement of my shot. I use the equation sine A over side A equals sine B over side B. After plugging in all my numbers, I figured out the displacement of my shot is 6.3938 meters. Therefore, the displacement of my shot is 6.39 meters. Work done by the ball. For the givens list, force equals 5.5414 joules, displacement equals 6.39 meters. Now we have to figure out work. I use the equation work equals force times displacement. I then plugged in all my numbers and figured out my work equals 35.4095 joules. When a stick is hitting the ball, the force is forward and so is the displacement. Therefore, positive work is being done. Power of the ball. For my givens list, work equals 35.4095, time equals 0.16 seconds. Now we have to figure out power. I use the equation power equals work over time. After doing all my calculations, I figured out power equals 221.3094 joules. Therefore, the ball produced 221.31 joules of power. For my givens list, E out equals 0.2029 joules, E in equals 0.443 joules. Now we have to find efficiency. To do this, I use the efficiency equation, which is efficiency equals E out over E in times 100. After doing all my calculations, I figured out the efficiency is 45.8%. Floorball stick with kick zone and tip curve. With these features on your stick, it causes your stick to flex more, which converts more to elastic energy, which will cause your shots to travel at a higher velocity.